Unit 3.03. Today we're going to be multiplying and dividing rational expressions. Nothing too crazy. So this should be fairly simple. Simplify and explain the rule by which you did so. So for each of these, go ahead and simplify, show all your work, and explain the rule that got you there. Alright. So here, when I multiply, I'm simply going to be multiplying the denominators and the numerators. And this will give me my new fraction. Now notice here that I have 3 over 9. 3 divided by 9 is the same as 1 divided by 3. So this is going to end up simplifying to 4 over 15. Same idea here, except I'm just writing this in general. So with any two fractions, I'm going to compute their product by multiplying the numerators and multiplying the denominators. So that is just the general rule for any two fractions. And we can extend this to rational expressions, because what is a rational expression? It's nothing more than taking a polynomial and dividing it by another polynomial. So here, if I have p of x, q of x, f of x, and g of x that are all polynomials, then notice what we have here. We have polynomial over polynomial times polynomial over polynomial. Well, a quotient of two polynomials is a rational expression, right? This here is just a rational expression. So what I'm doing is I'm multiplying two rational expressions. I want you to go ahead and pause the video and write this out as you think it would be. How would I compute the product of two rational expressions? So it's just like I would with any regular fractions, multiplying two fractions. I'm going to do the same thing. So I will multiply p of x times f of x and divide it by q of x times g of x. Okay? So what I'm saying is if I have two rational expressions, when I multiply them, I simply am multiplying the numerators, taking the product of the numerators and the product of the denominators, and those are that's my new rational expression. Alright, now let's take a look at division. So first, go ahead and read this through, and do you think it is the case that this statement here is the same as this statement here, and that those two are the same as this statement here? Go ahead and decide and then explain, and we'll talk in a second. Alright, so notice that this is a divided by b. Well, a divided by b, this is saying the same thing, right? A over b means take a and divide it by b. And then here's the one that might have tricked you. Is a divided by b the same as a times 1 over b? And you'll notice that it is, because a is essentially a over 1, right? And we remember from multiplication that when I multiply two fractions, I am multiplying the numerators and the denominators. So this would be a times 1 over 1 times b, which is, of course, a over b. Alright, so here's what we want to take away from this. Notice that if I am dividing two things, that's the same as taking the first and multiplying it by the reciprocal of the second. Right? So what we have is that a divided by b is the same as taking a and multiplying by 1 over b. Right? So I am dividing by b, it's the same as multiplying by the reciprocal. Okay, and so now go ahead with this in mind and think about this. Simplify, there's only one expression here. So simplify this expression and explain the rule by which you did so. So applying this idea that we got from up here, which is if I'm dividing two things, it's taking the first and multiplying by the reciprocal. What I can do here is I'm just taking the first 5/7, and instead of dividing by 2/3, I'm going to multiply by 3/2. Okay? So notice that instead of dividing by the reciprocal, instead of dividing by 2/3, I'm multiplying by the reciprocal. So these are doing the same exact thing. Okay? So now let's go ahead and compute that, and we know how to multiply fractions. I multiply to get the product, I take the product of the numerators, which will be 15, and the product of the denominators, which will be 14. And I can simplify this if I want. This will be 1 and 1/14. Okay. Now let's take a look at rational expressions. So same setup, right? I have these 4 polynomials, and so of course here p of x over q of x, this is a rational expression, right? As is f of x over g of x. And so just like with regular fractions, I can apply the same idea to dividing rational expressions. So if I am taking a rational expression and dividing it by another rational expression, what am I really doing? I want you to pause the video and try it yourself. Just like I did previously, I know that dividing by a rational expression or dividing by a fraction is the same as multiplying by the reciprocal. So I want to swap these. So I'm going to end up with p of x over q of x times g of x over f of x. Alright, and now we know how to compute this, right? We have p of x times g of x over q of x times f of x. And that will give me my rational expression. So remember, when I divide by a fraction, I'm really multiplying by the reciprocal. If I divide by something, it's the same as multiplying by the reciprocal. So if I'm dividing rational expressions, I'm going to take the reciprocal and multiply, and that will allow me to compute my rational expression. Alright, I want you to go ahead and simplify the following. Take your time. We will discuss these in class. Go ahead and simplify them, and I just want to talk about one more thing and have you answer one more question. Alright, so now that you've simplified each of these and you have gotten some new expressions, I want you to take a look at these 2 expressions here. Okay, and I want you to answer the following questions. When you multiplied 2 rational functions, so up here, when you multiplied 2 rational expressions, did you get a rational expression back? In other words, is this here a rational expression? And same question here, when you divided 2 rational expressions, did you also get a rational expression? Okay, so I want you to answer yes or no, and then I want you to say, do you think this is always going to be the case? So anytime I multiply rational expressions, do you think I'm going to get a rational expression? And anytime I divide rational expressions, do you think I will get a rational expression back? Go ahead and write that out in your own words, and then we'll talk. Okay, so hopefully you said yes, and it's just like any regular fraction, right? If I multiply 2 fractions, I'm going to get a fraction back. There's no way I won't. And if I multiply 2, or if I divide 2 fractions, I'm also going to get a fraction back. And rational expressions are just the same way. And so the term here, what we say is that rational expressions are closed. This is the term here. Closed under multiplication, and abbreviate, and division. Okay, so this is a fact. This is a fact that you'll want to write down. And what this means, what closed under multiplication and division means, is that whenever you multiply them, you're still going to get a rational expression. And whenever you divide them, you're still going to get a rational expression. So to finish this off, go ahead and just define for yourself what it means to be closed under multiplication and division. We'll check that tomorrow and talk about it.